On this 2019 to 2025 Chevrolet Silverado 1500 with the 5.3 gas engine, P0101 is a mass airflow sensor performance code. In plain language, the engine controller may be seeing measured airflow that does not line up with the airflow it expects. The truck may have a check engine light, may idle rough, may hesitate, or may feel down on power. The fault area can be an airflow measurement, throttle airflow, map input, intake or vacuum leaks, PCV and hose integrity, air or exhaust restrictions, or even an engine mechanical condition. If other power supply, throttle, map, or communication-related codes are present, treat those as context and check what they mean first, instead of forcing everything into a MAF diagnosis. Start with the basic system checks. Then follow a structured diagnostic approach. For P0101, the important idea is measured airflow versus estimated airflow. The monitor gates include engine coolant temperature, -9 to 129 degrees Celsius, 16 to 264 degrees Fahrenheit. Engine speed equals 400 to 5,700 RPM, and intake air temperature sensor equals -20 to 129 degrees Celsius, -4 to 264 degrees Fahrenheit. Once those gates are met, the monitor runs continuously for greater than 1 second. The code can set if the measured to estimated mass airflow ratio is too low for greater than 1 second or too high for greater than 1 second. Set and clear behavior follows Type B handling. With the ignition on and the vehicle in service mode, first make sure the related reference voltage codes are not set. If any of those are present, stop and diagnose that group first. If they are clear, look at throttle body idle airflow compensation. It should be less than 90%. If it is 90% or greater, the throttle body cleaning path is the next move before continuing this P0101 flow. If it is less than 90%, run the throttle sweep from 0 to 98% and back to 0%. Then confirm throttle position sensors 1 and 2 agree. If they do not agree, move to the throttle position diagnostic path. If they do agree, check the map sensor value against the correct altitude versus barometric pressure range. That exact table value has to be known for the vehicle's altitude. If you cannot verify the correct range, pause there and do not guess. If the map value is out of range, follow the map diagnostic path before continuing. Next, confirm whether the GE52250 variable pressure leak detector is available. If it is available, perform the component and system leak test and verify it passes. If that leak test fails, repair or replace only as the failed finding supports. If the tool is not available, the return point in this path is not clear, so pause, recheck the earlier diagnostic path, and avoid guessing the branch. Once leak testing is passed or the path is confirmed, check for the related physical conditions. Intake pressure and air temperature sensor seal issues, contamination or damage at the multifunction intake air sensor, throttle body coking or restriction, dirty or restricted air cleaner element, restricted or damaged catalytic converter, engine mechanical concerns, exhaust leaks or restrictions, cracked or loose intake ducting or manifold issues, PCV system leaks or restrictions, vacuum hose problems, and vacuum leaks around the oil level indicator tube or oil filler cap. If one of those conditions is actually found, correct that condition as necessary before moving on. If no listed condition is present, bring the engine to normal operating temperature and let it idle. At idle, the map sensor should be 26 to 52 kPa, 3.8 to 7.5 psi, and the value should change with accelerator pedal input. If the map value is not in that range or it does not change, go back to the map diagnostic path. If it does change, slowly raise engine speed to 3k RPM and then bring it back to idle. Now review stored data and watch the MAF sensor frame by frame. The MAF value should not spike or drop out. If it does spike or drop out, move to the appropriate MAF signal or communication diagnostic path instead of condemning a part without testing. If the MAF trace does not spike or drop out, reproduce the operating conditions for the code. You can also reproduce the captured conditions from the stored data. Then verify P0101 does not set. If it does set again, do not jump to a part. Go back to the beginning, recheck the basics, and work through the earlier path again. If the code stays gone, verify the repair and confirm the code stays gone. The takeaway is simple. P0101 is a comparison problem, so prove the inputs, airflow path, leaks, restrictions, map behavior, and MAF signal stability before making a repair decision. For more diagnostic training, visit stempdiagnostics.com.